Hello, my name is Ava Armstrong and my project is titled Heat Warming Gloves. There are a lot of heat/hand warmers out there, but I've never seen non-electronic heat warming gloves. My question is, what combination of chemicals are necessary to produce heat? The purpose of this experiment is to get the gloves to produce heat and for the heat to last up to 15 to 20 minutes, depending on how cold the external temperatures are. This can happen if I add more of the main chemicals that are producing most of the heat, which are calcium chloride and water. Calcium chloride can absorb enough moisture to convert to liquid brine. In other words, it is deliquescent. When dissolved in water, solid calcium chloride releases heat in the thermic reaction. The hypothesis that I had is that if we take the gloves outside into cold air, will have an effect on how long the heat inside the gloves will last because it is cold temperature. Therefore, adding more of the chemical that creates the heat, which is calcium chloride, and changing the amount of other chemicals in the mixture. For example, adding a tablespoon more of calcium chloride, adding water, and keeping the amount of iron filings the same, which will help make the heated gloves last longer in the colder weather. I think this because when the colder mass matches up with the warmer mass in the gloves, the cold air slides under the warm air and pushes it upwards. As it rises, the warm air cools rapidly. The warm air rises up because it's lighter. For my project, I did 4 different tests. The first test was my first attempt, and it didn't really work out well. I was testing how long the heat in the mixture would last. The second test was testing how long the heat in the mixture lasts indoors. The third test was testing how long the heat in the mixture lasts outdoors. And the fourth test was testing how long the heat in the mixture lasted when it was in the glove and outside. The heat in the first test lasted 9 minutes. The heat in the second test lasted 35 minutes. The heat in the third test lasted 15 minutes, and the heat in the fourth test also lasted 15 minutes. In all 3 tests, temperatures went way above 50 degrees Celsius and 120 degrees Fahrenheit for more than half the time. My final results were that according to my experiment, adding water and more calcium chloride to the mixture with the other liquids was very effective. On the second attempt, when I did it on the first try, when I did the experiment inside, it lasted 28 minutes longer than it did on the first try, and that didn't have any extra calcium chloride or any water. When I did the experiment outside, it lasted 8 minutes longer than it did the first time. Also, when I did the test outside with the gloves, it lasted 8 minutes longer. There was also a significant difference between the temperatures. Indoors, the normal temperature was 23 degrees Celsius when I tested tests 1 and 2, then added the calcium chloride. The temperature went over 50 degrees Celsius and 120 degrees Fahrenheit. When I did test 3 and 4 outside, the normal temperature was minus 5 degrees Celsius. Then with the calcium chloride, the temperature went over 50 degrees Celsius and 120 degrees Fahrenheit. In conclusion, during this experiment, I found out a lot of new things, like calcium chloride is the main heat source in the mixture. Calcium chloride is also a salt, and that when the bag that the mixture is in is open, it will have an effect on how the heat is making, and it might not last that long. I also learned that when you put the heated gloves in a colder temperature, it does have an effect on how long the heat in the gloves lasts. Another thing is that there's a big temperature difference when you do the experiment outside and inside. I found this because when I did it inside, it lasted 35 minutes, and when I did it outside, it only lasted 15. Possible errors during this experiment are that when I tested out the experiment, the mixture didn't last very long. I fixed this by adding water instead of water beads, and also by adding more calcium chloride. This way, while the calcium chloride was absorbing the water, it's also producing heat. What I enjoyed about doing this project is that I was able to create heat inside of a glove that lasted for 15 to 20 minutes. If I were to continue the project, the next step would be to figure out a way so that when the gloves are outside, the heat in them doesn't only last for a short amount of time. Thank you.